right, excellent. So thanks for the introduction, Ron. Yeah, I'm Aaron Howell. I'm the managing consultant for our multi-cloud architecture and innovations team. I've been with SynerComm now for almost 10 years. I kind of joke that I was doing their internal work for a while. We started getting in the cloud about 2015 or so, and I must have done something wrong because then they put me in front of customers, and I've been there ever since as a consultant. So. For this particular talk, we're going to be talking about the cloud defense. I'll be going over common findings and hopefully some controls that'll just have you guys start to think about different things in your environment and just thinking about the security that could then be put around them. So with that, this is just a high-level overview. So we'll be talking about kind of the pitfalls that we see for our customers as we do pen tests, as we do audits and assessments. And hopefully then we'll dig into some of the more technical findings, such as server-side forgery requests and some S3 bucket portions. We'll explain a little bit more about why those findings are important. And then we'll talk about the remediation pieces of some of those and then rinse and repeat. So we've got a few examples. So first, let's just talk at a high level. I know a couple people have gone over this already, but the cloud architecture. So why do people want to migrate to the cloud? Well, the great thing is, it's adaptive, elastic, it changes, it's very ephemeral. You can change things very quickly. You're focusing more on the services, but not the servers. I know a lot of my customers, they go, well, I don't have any, as we're doing an audit, I don't have any VMs in my environment, so I really don't have that big of a cloud presence when it comes to Azure or AWS. And I go, okay, that's understandable, but what services are you actually utilizing? And then it turns out that they're using 10 or 15 different services within the environment. They might not have a traditional architecture, but they're using the Lambdas or the application functions, those kind of things. And that all ties into it to something that could potentially be exploited. So making sure that your security is around that is very important. Another obvious portion of using cloud is the resiliency of it. Being able to spin up in multiple regions or in multiple AZs with different data centers, not having to worry about creating your own with multiple plugins for power, those kind of things, or multiple ISPs, that definitely adds on to it. So this is just a whole high-level overview of that. Obviously, because we're all talking about cloud right now, we don't have to get too much into it, but I just want to start getting the mindset into what we're thinking. So cloud security at its finest. At a high level, what should you do in cloud security? Well, definitely you want to utilize cloud features for defense. There's plenty of different ones that are mentioned. I know Brady just mentioned, Macy. There's Security Center in Azure. There's a lot of different features that you can utilize as just a consumer of the cloud that's already pre-baked or built into the APIs that you can utilize. So definitely when you're utilizing services, or if you're even taking just a traditional lift and shift approach, make sure that you utilize those flows, those functionalities within the cloud itself, understanding what security might be available to you, and then what you might have to add on to a third party. There's a great thing that kind of came out a few years ago, CPSMs, right? Cloud or CSPMs, Cloud Security Posture Management. Prisma Cloud is one of them, as well as CloudGuard is another. Those are just a couple that I'm familiar with. But basically being able to monitor your environment outside and above beyond what like AWS or Azure could potentially do. The shared security responsibility model. So understanding exactly what you as a consumer of the cloud are responsible for, rather than just assuming that, oh, well, I built it in the cloud, so shouldn't AWS take care of everything? Well, not necessarily. Different services have different levels of the responsibility model. So making sure that you understand where do you become responsible for that data, and where does the cloud provider actually then handle the responsibility. Obviously, we understand that, like, for instance, if it's the host itself, well, normally the host is going to be handled, the actual physical host is handled by the cloud service provider. However, if you're talking about the VM and keeping the OS up to date, you understand that that's going to be your responsibility. Or if you're using a managed service provider, that'll probably be their responsibility. Another piece is reducing your privileged access. So a lot of times we run into customers who, developers, they basically have open wide development privileges across the board, even in production pieces, because they need to connect to different production pieces, maybe the production database, to be able to tie into these things. So, but you have to understand that as even though it's more open, you're still able to utilize those privileged access. So even if, let's say, your developer isn't a known bad actor, someone could get hold of those privileged access and be able to then utilize that to then compromise your security in production. So understanding where your access is and then leveraging those IAM roles, those security groups, all those different things, being able to pull that in and really tying down. Now, not necessarily handcuffing your developers, understanding exactly what they would need to accomplish their tasks, but at the same time being able to reduce those privileges so they can't just escalate into, for instance, spinning up an internet circuit and connecting into an internet from a different network that you don't want access to because you're trying to restrict it all through, let's say, a third-party firewall or an integrated firewall in AWS or Azure. Creating scripts and automation, that's a big thing. I know Brady just kind of talked about this a little bit, but being able to create that robustness of being able to spin up pieces, be able to spin up the security, being able to spin up the different VMs in an automated fashion, so where now you're actually looking at the reduced privilege access, because now your developers don't actually have access directly into the environment. They actually run through the CI dev pipeline, and that's what actually leverages the permissions to be able to create these things. Obviously, with creating scripts and the automation piece, it also adds resiliency. I've had customers who will build Terraform scripts or CloudFormation scripts that they're able to rip apart the entire environment, recreate it in a completely different region, so that way if there is a problem somewhere, they can just basically scrap the whole thing and then rebuild it, and they're able to get back up and running in a matter of minutes. You can't really do that on production or in on-prem. And then obviously testing and auditing. That's kind of where we would come into play. We do a lot of pen tests, assessments, audits inside the cloud. Just because it's not on-prem, if it's got your data and you need compliancy for X amount of things, a lot of places, require pen tests or they require audits. You need to make sure that you're following that for whatever compliancy that you're following, not only on-prem, but also in the cloud. So making sure that you understand those compliancy requirements, being able to translate them up into a cloud aspect, and then be able to then execute on those and show that you're compliant. Moving on, some cloud security pitfalls that we find: prioritizing the security strategy ahead of the controls and tools. So that would be the opposite, right? When you start looking at what you want to do, is you want to look at the security strategy as a whole rather than just buying those tools. I mentioned the CSPMs, right? That's not a silver bullet, or buying Amazon Macie or looking at Security Center or Security Hub or all these different things. It's the same concept as buying a SIM on-prem and assuming that, well, I have a SIM, so I'm compliant. Well, technically you are, but are you actually logging to that SIM? Is it configured correctly? That's the same thing. So understanding your security strategy before you go out just running all those tools, buying all those, listening to all the buzzwords and everything, being able to secure across that. Overcoming the lack of security visibility in the cloud. So I've mentioned that there are a lot of security tools out there. However, there are certain visibility issues, specifically when it comes to compliance. And it's getting a lot better. But as we kind of go on, there are a lot of places where you might not understand, where is my data? How is this networking through the environment? So by utilizing these tools, understanding your security strategy, you should be able to then kind of overcome that lack of security or that visibility. Improving confidence in your cloud provider security. So when it comes to that cloud shared security model, understanding where that cloud provider starts or where it stops and you start, that's very important, especially when it comes to compliance, to be able to go back to the auditor and say, yes, the hosts are being taken care of, those kind of things. And each one of the cloud security cloud providers do have a cloud shared model that are listed on their websites that you can use to help kind of determine where that responsibility lies. That also kind of falls into the who is liable. Understand why attackers are attracted to the cloud. Well, the main thing is because of the way the cloud is normally adopted. This was true a few years ago, and it still is true today, is a lot of customers and a lot of, I guess, people who are starting that migration or starting their journey into the cloud don't understand it all that well. They might not understand, how does the network work? What is the underlay? What is the overlay? How are the permissions being shared across the environment? So they keep it a little bit more wide open. Well, obviously, if you have production data, me as an attacker, I'll be very interested in trying to get that production data. And it might be easier to go after your cloud, which might have less security around it than your on-prem. Examples are like the S3 buckets from like 2017, where there were a lot of larger organizations that were getting hit by public S3 buckets. And basically having their data exfiltrated from their systems and not realizing that their data was already out there, just open to everyone. Defending against curious onlookers in multi-tenant infrastructure. So that one, you want to make sure that, especially when you have multi-tenancy, so if you've got, let's say you have multiple tenants in Azure or AWS, being able to, if I can get into the top level of your multi-tenant, I should then be able to go across all your other tenants, right? So making sure you have the security, not just in the environments that you're talking about, but then the overall security, the IAM rules, all those kind of functionality, the Azure Active Directory pieces, making sure that we have all those locked down so we can't just proliferate into a multi-tenant infrastructure. And then I've talked a little bit about this, but obviously addressing your compliancy regulations. So you want to make sure that just even as you start your cloud journey, or if you're further down into it, that you're making sure that you are aligning your strategies, you're aligning your cloud to your compliance regulations, be it if you're a bank with PCI or holding credit cards, the FFIEC, all those kind of things, making sure that you understand those. So we're going to kind of get into the more root of this, and this is pen test findings that we commonly see. The metadata endpoint. So metadata endpoint, and I'll show you guys a little bit of this later, but basically that is the information that like the EC2 instances, the VMs, all that kind of pull in to understand what their roles and responsibilities are, what kind of permission sets they have, everything like that. These are available in both the Azure and AWS cloud. And basically, if I can get to the metadata endpoint, I can get security credentials that I can spoof then to be able to proliferate across based on the permissions that I can find. Storage, we talked a little bit about, but the S3 and blob storage, making sure that we don't have public. That's another one that we find. Policies and permissions. That's that would probably be one of the highest level ones that we'll be able to see. And it is fairly easy to understand too, right? So if you've got 10 different admins, global admins in any cloud environment, I guarantee you that's going to be a red flag, at least if you're doing a CIS template, assessment or anything like that. So just making sure that you understand those. Asset management, making sure that you understand what's all in your cloud environment when it starts, understanding when things get taken down, spun up, if you're utilizing the flexible, anyway, the whole being able to expand across multiple applications, those kind of things, that's all important to understand. Subdomain takeovers, this one popped up probably about 2 years ago. Basically, if I'm an attacker and I see that you might not have taken care of your DNS correctly, I can take over a subdomain. And then Kubernetes exposure to API and internet, making sure that your Kubernetes is locked down. So let's first talk about SSFR, which is server-side forgery requests. And this is actually a use case that got hit. A bank back in 2018, I believe, got hit with this, but we want to just kind of talk a little bit about it. So specifically, it was an insider threat. There were multiple organizations that have been subjected to this attack. And like I said, it's a server-side request forgery. So basically what you can do is you can pretend that, or you can utilize a server that might be vulnerable to this to be a proxy for yourself. That proxy will then be able to basically make web calls on behalf of that server that would be compromised, and whatever permissions that server has, then basically that client or that attacker has those permissions. Once the SSRF is completed, the AWS Medpoint itself can be compromised, and we talked a little bit about that. But basically, once we have that proxy, we can then pull out tokens, security codes, all those kind of things to be able to then spoof even more. And then the metadata itself, so understanding exactly what's in that metadata. So here's a high level of how this attack works. So basically, the vulnerable server is used as a proxy, like I said before. Once it's identified, you can actually hit the 169.245, 169.254 for the metadata IAM information. If you get a 200 OK, and this is specific to AWS, understand that. But if you get a 200 OK, basically that means that there is a role assigned to that EC2 instance, and you're then able to then pull that information out. How you pull that information out is you actually go into the metadata again and you look in the security credentials. That'll then return a security role that's assigned to the EC2 instance. Once that credential has been stolen, then we can actually go into the role name and pull out the access tokens from that role. So now I've got the access tokens for that particular role, and I can now start looking at potential other compromises using those credentials. Here's a little just quick eye chart of that. So at the top here, you'll see that we've got the proxy going and it returned a dynamic metadata user data. The second one there, EC2 default SSM, is the role that was assigned. And then the third one there, that's actually, as you can see, there's the secret access key there with the token information. So that all can be pulled in directly from that metadata. So the EC2 instance that this particular one is calling had the server side forgery request problem. And from that, we were able to then utilize the proxy to be able to pull that information. Here's all the information that's actually stored in the metadata portion itself. So we've got the IAM, all that kind of stuff. The information that we are interested, obviously, is the IAM with the security pieces. But it's always good to know what's actually out there. So you definitely want to protect these pieces, these metadatas. Lessons learned from this one. All metadata is needed to be secured with access. Host-based firewalls are great, whitelisting, GPOs, not just your network security groups, right? Because that's not going to do it because these EC2 instances, VMs, whatever, need access into that metadata. All those services need access to the metadata to be able to pull out the information they need. So just be aware of that. And obviously, you should test if it's external facing. You should always test for SSFRs. You should be testing for any real vulnerabilities going in. Here's a DNS subdomain takeover. Basically, what we would look for is what's called a dangling DNS record. What that means is someone associated an external DNS with a record, and normally it's a CNAME, with like a Route 53 or a public DNS in Azure. Once that's identified, if you delete a subdomain in that section but don't actually delete it, so if you delete the subdomain from your cloud DNS but don't actually delete it in the higher level DNS records, you can actually basically do a subdomain takeover. We've done this a couple times where we'll take over a billing proxy portal that was just a test server. Now it looks like we basically have access as a customer looks at it. We can now take over that domain and then be able to put in whatever bad code we would want, be able to pull in information. So once done, delete or remove subzones without removing a pointer at the domain registrar is really what that end is. So this was a big one that you just want to make sure that you're doing DNS sanitization. So remove name server entries corresponding to deleted zones from the domain registrar itself. And then DNS zones should be monitored for removal activities. And if you've got automation or anything like that, then it should trigger alerts and then create remediation actions, be it automatic or just manual. Understanding that, so that way no one takes over your subdomains and basically pretends to be you. Credential management, this one's kind of, it's definitely included, especially when it comes to the CI pipelines, but basically, make sure that you don't have the hard-coded passwords, plain text storage and passwords, right? It's just kind of the stuff that we think about already on-prem, but making sure that you translate that over into the actual cloud portion too. So making sure your devs don't just throw in some kind of connection string inside of the code itself, because then potentially an attacker would be able to pull that in. Remediation for those is obviously avoid the risky storage or risky code practices in general. Never store sensitive information in accessible formats or locations. Always encrypt when dealing with any credential, even if it's just for test purposes or something like that. Just make sure that you encrypt them. And then limit permissions credentials to only what you need. So again, going back to those permission levels, if that credential is ever compromised, understand exactly what that credential might be able to access. Again, you don't want to be giving EC2 instances or VMs the run of your entire environment if it only needs to call one or two services. Last one is the S3 buckets or public storage in general. Publicly accessible buckets with information stored should never be public, or should be identified what information is actually on there if it's publicly accessible. If not, if there's no reason to be publicly accessible, then just remove it, right? It's a pretty easy little checkbox. Don't use any common names that are easily guessable. You can't actually pull out those names unless it's hiding in a website somewhere. So it's not like I can enumerate those, except for if I've got access to the metadata. But the common names itself, so if I've got just like storage .synercom.com, for instance, right? We don't want that easily guessable, so I can't just be hit by a spray attack. No use of access controls or permissions. That kind of brings us back to that whole permissions piece, making sure that you understand the permission levels of what those buckets need, and then being able to utilize that. Data not encrypted and no visibility into the access itself. So making sure that you utilize those cloud API checks, CloudTrail, CloudWatch, all those different pieces, Azure Sentinel, being able to understand who's accessing those buckets, why. Because if I, as an attacker, can upload something into those public buckets, then potentially I might be able to run code on it, and you definitely don't want me running code on that. I could then leverage that as just kind of like the SSRFs, being able to then identify the metadata, or being able to pull tokens, being able to spoof something, or being able to even spin up things in your services that cause your billing to go up, being able to leverage virtual machines, those kind of things. So just understand that. Obviously, with those remediation, I talked a little bit about that as we were going through. IAM rules, and then encryption is a big one, right? Making sure that, especially if it's going to be sensitive data, that it's encrypted to its fullest. So that's basically all I have at the moment. But yeah, so SynerComm offers services for assessments, pen testing, those kind of things. We utilize and do this a lot of time. We've gotten pretty proficient at it. We've been in the cloud now, like I said, about 4 or 5 years. We recognized it early on that this was going to be something that our customers were interested in. And we basically built the practice around that. So SynerComm itself has been around for 35 years. And our focus has always been security. In the data center, we understand the firewalls, networking, switching, and that also translates over to cloud, especially when you're doing some kind of build. So keep us in the mind if you guys ever have problems or just want to chat about security in the cloud. Thank you.